Dear students, today we are going to discuss the last topic in Unit 1, which is about points of intersection of a straight line and a quadratic curve. Let us consider a curve and a straight line crossing this curve at 2 points. So there are 2 points of intersection between the quadratic curve and the straight line. There's a possibility that uh, there is only the line intersecting the curve may intersect the curve at one single point only. And in this case, we say that the line touches the curve at a single point, and this line is called tangent. You already are familiar with the idea of tangent. There is a possibility as well that the line doesn't touch the curve at all or nor intersect the curve. Okay, so there are no points of intersection. So here we have 2 points of intersection. Here 1 point, and here no points of intersection. Okay. Now you also know that if we need to if we need to work out these points of intersection of a line and a curve, we can solve the equation simultaneously and then get the values of x or value of x. Okay, so you already have done or learned how to solve quadratic simultaneous equations when one is a linear equation and the other is a quadratic equation. Okay. Our today's topic is basically finding the number of points of intersection when we are looking into a straight line and a quadratic curve. So, finding number of points of intersection between a curve and a straight line. So yesterday we discussed about the discriminant of a quadratic curve or quadratic function, and here also we'll use the discriminant again to decide that how many points of intersection are there between a straight line and a quadratic curve. So first of all, you need to solve or simplify the simplify simultaneously both the equation, simplify simultaneously the equations where one is linear and the other is quadratic to get a single function. This single function will be a quadratic function, and once you get this single function, use discriminant as we discussed earlier. Okay, so we know that if the discriminant is b square minus 4ac is greater than 0, then there are 2 roots. Okay, there are 2 roots of the equation. So 2 roots mean there are 2 points of intersection between the line and quadratic curve. Okay, similarly, if b square minus 4ac is equal to 0, then you know that repeated root or we can say that a single root. So therefore a line touches the curve at a single point. And finally, if b square minus 4ac is less than 0, we know that then the discriminant is negative, and square root of negative is not a real number. So we said that no real roots. If there are no real roots, no point of intersection between the line and the quadratic curve. Okay, so basically this is again the application of discriminant in order to find the number of points of intersection between a straight line and a quadratic curve. Thank you.